Hello, fellow problem solvers. So today we're going to be doing the problem from the 2024 IMO, problem number 1. I suggest you try this nice problem out for at least 10 minutes, ideally 45 to maybe an hour and a half, not more than 4.5 hours, because that's the time that you have at the IMO anyways. I invite you to put your first ideas out on paper for the next 5 minutes, and now let us begin. So we have determined all the real numbers alpha such that for every positive integer n, the integer alpha plus 2 alpha plus all the way till n alpha, the floor of all of these is a multiple of n. And I've written out some floors. The floor of pi is 3. The floor of negative 2.5 is negative 3. The floor of 5 is 5. So now I invite you to take 5 minutes to try out this problem. And now let us begin. So what is going to be sort of the first order of business? Well, the first order of business is going to be, okay, let me see what happens to this function. So let's actually call this function that we have here, let's call it f of n. F of n is equal to alpha plus 2 alpha, the floor of 2 alpha plus all the way till the floor of n times alpha. So this must always be divisible by n. Okay, so now what are we going to do? So the first things first, like we just saw the problem, we don't know much about it. Let's play around with some cases. Say the case for n is 2. We have 2 divides the floor of alpha plus 2 times plus the floor of 2 times alpha. Now, what does this mean? Well, if 2 divides the floor of alpha, then 2 must divide this, and the other way around. If this is odd, this is odd. So let's look at some casework. And the casework says, okay, we're going to have this is, say, if this is even, then we know that 2t is less than or equal to alpha, less than 2t plus 1, which implies once we multiply by 2, 4t less than or equals 2 alpha less than 4t plus 2. And here I invite you to pause for 3 minutes and tell me, what can we conclude from this, given that this one must be even in this case? I hope you paused, and the answer is, well, from here, given this must be even, the floor of this must be even, we can conclude that 2 alpha is in fact less than 4t plus 1, strictly. If it was more, you'd have a contradiction. This is a key idea, key fact. He's sort of like playing around with these sort of floors. If you don't understand it, pause for 5 minutes and think about it. So now this implies that once we divide again by 2, that in fact alpha is less than 2t plus a half. Now we have a better constraint on alpha in this case. What if alpha is strictly less than 2t, but it's greater than or equal to 2t minus 1? Okay, then 2 alpha is greater than or equal to 4t minus 2, and strictly less than 4t. Now, again, what can we say about 2 alpha? Well, we can say that this number must in fact be greater than or equal to 4t minus 1, because its floor must be odd. It can't be even. If it was less than 4t minus 1, its floor would be even. So we now know this to be the case. And then, once we divide, we know this is in fact less than 2t minus a half. So now from these two cases, we have figured out that alpha, just from F2, we have figured out that alpha is between 2t minus a half and 2t plus a half, where this is a closed interval over here. So now here I invite you to pause for 3 to 5 minutes and think about this problem a bit more, maybe a very global view. And now let us continue onwards. Well, the next sort of idea is, wait a second, okay, let me try to see if I can find any solutions to this problem. And it seems like, wait a second, if alpha is an integer, alpha can be a real number if it's an integer, then this whole thing is going to be equal to k plus 2k plus all the way till nk, which is, what is it called? This is n times n plus 1, k over 2. Now this is always going to be divisible by n if and only if this number is an integer, which is true for every n, namely for even n, if and only if k is in fact divisible by 2. We could have also figured that out from here. So 2 must divide k, and if 2 divides k, then this is definitely going to be divisible by n. So even integers k work. So now this sort of tells me that I could be wrong, But for every n, like my intuition is telling me maybe it's just the even numbers and I can like sort of constrain this. This is also wishful thinking. Maybe, okay, for 2 I get less than a half and greater than a half. What about for 3? If you haven't played with the case. F of 3, I invite you to play with it now for the next 3 minutes. And let us now do that. So, we know alpha is between these two numbers. Now, what the floor of alpha and the floor of 2 times alpha are is going to be determined like where alpha is in terms of this. Namely, let's look at the first case. If we have that alpha is, what's it called, less than or equal to 2t minus a half, greater than or equal to that, and less than 2t. Then we know that the floor of alpha is 2t minus 1, and the floor of 2 alpha is going to be equal to 4t minus 1. So then we have 3 divides, what is it called? Actually, and what is 3 alpha? 3 alpha is going to be less than or equal to 6t minus 3 halves, strictly less than 6t. So now we know that the floor of 3 alpha is either going to be 6t minus 1 or 6t minus 2, but nothing else. So I know that this divides 2t minus 1 plus 4t minus 1 plus the floor of 3 alpha. So you have this, and then 3 divides the floor of 3 alpha minus 2, add 3, floor of 3 alpha plus 1. So I have 3 alpha is going to be equal to 60 minus 3 over 2. So if it's between minus 3 over 2 and minus 1, if 3 alpha is there, then we're going to have an issue. Then we're going to have that, we have an issue. Well, let's look at what that translates to here. So how can we think about this now more formally? So let's say alpha, what does this imply? Because it's either 60 minus 1 or 60 minus 2. The floor of this must be 60 minus 1. And now what do we have? We have that the floor of 3 alpha is equal to this, which implies what? That 3 alpha is greater than or equal to 60 minus 1, which implies alpha is greater than or equal to 2t minus a third. Oh, look, we're getting closer in this case. But now let's look at the other case. And here, invite you pause for a minute, think about this, and now let's go to the next case. What happens when we have that alpha is between 2t and 2t plus a half? Okay, so let's think about this. Like, what do we have? We have that the floor of alpha is equal to 2t, the floor of 2 alpha is equal to 4t, and we have that 3 must divide this plus this, it must divide the floor of 3 alpha. Now the floor of 3 alpha is, so it's between, alpha is between 60, 3 alpha is between 60, and 60 plus 3 halves. Again, 3 alpha now, the floor of this is either 60 or 60 plus 1. So we must have that, what's it called? This thing over here must be either 60, because it must be divisible by 3. 60 plus 1 isn't divisible by 3. And now we have that, so if it's 60 plus 1, that means this is less than 60 plus 1. If it's 60, this must be, 3 alpha must be less than 60 plus 1. And so alpha is less than 2t plus a third. Now here, pause for the next 10 minutes and finish up the problem. And what is the solution to the problem? Well, we solve this problem basically inductively now. 3 gives us this idea, 2 gave us like some work, and then like wishful thinking, we found a solution, and now we say, okay, let us finish this up. So let's do this inductively. Let's say the inductive case is that alpha is between 2t minus 1 over n and 2t plus 1 over n. Now we're going to prove that for n plus 1 must divide alpha plus all the way till floor of n alpha plus the floor of n plus 1 alpha. Okay, so let's think about this. Now let's look at, again, casework. First case. Alpha is equal to 2t minus 1 over n plus some epsilon. Epsilon is greater than or equal to 0 and less than 1 over n. So it's between this and 2t, right? Now this is me formalizing everything. Then k times alpha is going to be equal to 2tk minus k over n plus k epsilon. Now, what is the floor of this? So now we are looking at k epsilon. We know that k is less than or equal to n, greater than or equal to 1. So k over n, greater than or equal to 1 over n, less than or equal to 1. So, and now we have also here, actually this is not, yeah, this is k epsilon. And we have this is actually just k times epsilon minus 1 over n, right? So now what do we have with this? Well, we basically know that this thing right here is going to be, so this is going to be negative, but given that this is at most minus, so epsilon minus 1 over n is going to be greater than or equal to 1 over n, this is going to be greater than or equal to, I mean, let's say greater than, then we're actually looking at the k, actually greater than or equal to k over n. All right, so epsilon minus n on both sides, greater than or equal to minus n, actually, so it's minus k over n. So now we know that this will be between minus 1 and 0. And so this is going to be some fraction between minus 1 and 0. Actually, this part over here is some fraction between minus 1 and 0 minus this. So we get that the floor of k alpha is equal to 2tk. And then we decrease something by less than minus 1. We decrease something by less than 1. So you get that this is the floor of k alpha. For every n, for every k, that's less than or equal to n. And now what do we have? We have that this whole sum over here that we have, n plus 1 must divide 2k, and this is all the way till n plus 1, so n times n plus 1, actually no, 2t, I keep confusing, I use t here, 2t, n times n plus 1 over 2, so it must divide this, and then we have plus n plus 1 alpha, and I have minus n. So now we can get rid of this, we can add n plus 1, and we get n plus 1 divides the floor of n plus 1 alpha plus 1. Now, what is the floor of this? So the floor of this, given this estimate, n plus 1 alpha is going to be greater than or equal to 2t n plus 1 minus n plus 1 over n, and it's going to be less than or equal to 2t times n plus 1. So now the floor of this is either 2t n plus 1 minus 1 or minus 2. Now given that this part must be divisible by n plus 1, the floor of this must in fact be equal to 2t n plus 1 minus 1, which implies what? That n plus 1 alpha is greater than or equal to this, which now, when you divide by n plus 1, implies that 2t minus 1 over n plus 1 is less than or equal to alpha. So now we proved this side, and on the other side, we are proving this induction, and on the other side, if alpha is equal to 2t plus epsilon, where epsilon is less than 1 over n, then now the floor of k alpha is equal to the floor of 2tk plus k epsilon. This thing right here is less than 1, less than or equal to, actually strictly less than 1, because this is strictly less than 1 over n, for all k less than or equal to n. And so this function, f of n plus 1, divisible by n plus 1, becomes 2. So the floor of this, like 2tk, an integer, plus something less than 1, is going to be 2 times t1 plus 2 plus all the way till n. Again, this cancels out, plus the floor of n plus 1 alpha. This is divisible by n plus 1, so we have n plus 1 must divide the floor of n plus 1 alpha, and to top it off, what is n plus 1 alpha is equal to n plus 1 2t plus epsilon n plus 1. In other words, what did we have? We had alpha was greater than or equal to 2t, less than 2t plus 1 over n, multiply both sides by n plus 1. Alpha was greater than or equal to this, and less than 2t, n plus 1 plus 1 plus 1 over n. And now, the floor of alpha is either going to be this, or this plus 1. And so, given that n plus 1 must divide it, its floor must be this. So this must in fact be this. In other words, alpha must be less than 2t n plus 1 plus 1 and greater than 2t n plus 1. Divides both sides by n plus 1 and you get 2t, alpha is greater than that, and less than 2t plus 1 over n plus 1. This finishes up the problem, and as always, thanks for problem solving.